Last year, we studied linear relationships, and specifically, we identified if lines showed direct variation. Direct variation, remember, means that if a line goes through the origin and is a straight line or has a constant of proportionality, it shows direct variation. Just remember, the origin can be seen in a table as 0, 0, and a constant of proportionality, if I can't see a graph and identify if the line is straight, then we have to actually show this in a ratio or fraction form. So constant means consistently, something that's happening over and over and over. Proportionality is a fraction, so proportion means fraction. So if I have my y over x fractions that are identical, meaning the same thing throughout, then I know it shows that constant of proportionality. So again, I did all my y's over x, 10 over 2, 5 over 1. I'm getting those from my table here. And all the way across, all those fractions are equivalent, showing a growth of 5. So we're going to move into something just a little bit different, but along the same lines in our linear relationship. So this unit, we're studying lines that can show direct variation, but now we're going to start to get into the lines that don't, the actual lines that don't go through the origin. So we need to figure out, we know that those lines are straight, but we need to figure out at what growth rate are they increasing or decreasing by. And today we're going to talk about rates of change. All right, so down below I've listed 4 tables, A through D, and today we're going to look for rates of change, and then also, if I know that these are not necessarily direct variation graphs, I need to know where they start. Where do they intersect the y-axis when x is 0? I know direct variation starts at 0, 0 at the origin, but these don't. All right, let's take a look. So we're going to take a quick look at the table for A. I see my start value here, 0, 7. And I know that that's my start value because that's when x is 0. So I'm going to put here start value, SV. Okay, just so you're real clear, start value. And today, instead of writing just fractions y over x, because all of these wouldn't be equivalent, if I did 15 over 1, that is not going to be the same as 13 over 2. So I know it doesn't show direct variation, but it does have a growth rate, and we need to find it. So I'm going to show you how using a very similar fraction. So when graphs do not show direct variation, but we know that they're aligned, we're going to use this fraction, the change in y over change in x, to find our rate of change or our growth. So this little symbol, this triangle, means delta. It's a Greek symbol, and it means change in. So we're going to find the change in y and put it over the change in x, making that ratio. So I'm going to show you how. We're going to go from 15 to 13. My change in y here is a 2, but I don't know if you can note or if you can see that or not, but it's decreasing by 2. And I'm going to do the same thing for my x's. From 1 to 2, I'm increasing by 1. This is my change in y. This over here is my change in x. So I'm going to write my ratio. I'm going to write -2 over 1. And this right here is what my graph or my table of this linear relationship is growing by. So again, start value is 0, 17. And my growth rate or my rate of change is -2. If I was going to relate it back to our recursive sequences that we're currently doing, just remember my start value for this one is 17, and I could say that my operation is -2 because my table is decreasing by 2 for every 1x. All right, let's take a look at B. So I'm scanning through my table and I don't see when x is 0, but we can expand our table a little bit to find out whether or not it does either go through the origin or where it intersects the y-axis. So I know right here between -1 and 1, I'm going to find when x is 0. So I'm going to expand that table out. -1, 19. I'm going to put a 0 in here and a 1. And we're going to figure out what this is growing by. So if I go from 19 to -1, my change in y is subtract 18. And if I go from -1 to 1, I know that my x, my change in x, is +2. Oops. So when I write my ratio for this one, I'm going to write here -18, which is my change in y, over 2, which is my change in x. I'm going to simplify this fraction and I get negative 9 as my rate of change. So if I was going to go through and identify some start values and rates of change, we'll summarize that just when we figure out what this start value is. So if I know that I'm decreasing by 9, then I'm going to subtract 9 from 19 to get 10. And let's verify, does 10 minus 9 equal 1? Yes. So I'm going to go ahead and really quickly just erase this one from the other one. And I'm going to say here that my rate of change is negative 9 and my start value for this one is 10. So it's really important to think too that if I bring it back to our sequences, we can also say our operation is negative 9, start value is 10. Okay, just so I have a little bit more room, I'm going to go ahead and erase the other ones, and we're going to take a look at C and D. So while I'm doing that, I want you to pause your video, and I want you to be able to find what you think the rate of change is for C and D. So go ahead and pause. Okay, so hopefully you unpaused and you identified what your rate of change is. Let's go ahead and find it. So again, we're going to do change in y over change in x. My change in y here is plus 1. My change in x over here is plus 5. So if I wrote my ratio, change in y over change in x, my rate of change would be 1/5. We could call this our rate of change. We could even say that this is the operation for this particular sequence in a table. Now, if I have no idea what my start value is, I could always bring this table backwards. So I'm going to go ahead and erase this because I'm going to bring this back. And I'm going to go ahead and fill in the 1 here. And if I know I'm adding 1 going downward, then I should subtract 1 going upward. Just like here, if I'm going to add 5 going downward, I'm going to go ahead and subtract 5 going upward. And I'm going to keep going. I'm going to do negative 5 here, and I'm going to keep going here to 0. So our start value is right here when x is 0, y is 1. So this is our start value. Okay, let's take a look at D. I'm going to go ahead and erase this one. Hopefully you got your start value there. Our start value for this one I can't see, so let's find that rate of change. And remember, because it's a linear relationship, you can pick any 2 points that are in the table to identify your rate of change if we know it's a linear relationship. So I'm going to pick these 2 because they're positive. I'm going to go from 1 to 12, so 1 to 13, I'm increasing by 12 for my change in y. Going from 2 to 5, I'm increasing by 3. So my change in y is 12, my change in x is 3, and if I simplify that, my rate of change is 4. I could even say that that's my operation, what I'm increasing by. And then my start value, I'm going to take these two parts of the table and I'm going to spread them out. And when I do that, I'm going to put negative 15 here and I'm going to put 1 here, and we're going to fill this in. So if my growth rate is 4, if I'm increasing by 4, I'm going to add 4 to negative 15 to get negative 11. I'm going to add 4 again here, which is negative 7. I'm going to add 4 again, which is negative 3. And then I'm going to add 4 again and verify, yes, I would get to 1. So my start value for this one is negative 7. I hope that you realize some deep connections between what we did last year and what we're doing this year. Remember, our goal is to find the rate of change by doing the change in y over the change in x. And I wanted to tell you too, you could still do it here. Change in y here is 5, change in x is 1. So I still get that ratio of 5 over 1. So you can use that strategy up here for direct variation. And remember, if you don't know what 2 points to pick to find your rate of change, like I picked these 2 right here, you can pick any 2 points. So let's clarify that one more time again, that if I wanted to use, let's say these 2, if I increase from 13 to 21, 7, 8, I'm increasing by 8. And if I go from 5 to 7, I'm increasing by 2. So my change in y over change in x is 8 over 2, but it means the same as 4, just like I got when I picked 2 other points. So again, we're finding start values and rates of change. And I hope this video helps. Make sure that you take notes and be ready for class next time. Thank you.